Hey people, welcome to Dropminted, and this is a set of new videos in which we will be discussing and I'll be teaching you the FPGA flow in Vivado. For the FPGA flow, it will be like 2 or 3 videos in this series, not like a series but a couple of videos coming together. So in this video, we will be starting with the RTL and completely doing a full flow of Vivado for the FPGA. So in this video, we will be designing some RTL design for a simple design. So we can use that to actually generate a bit stream for the FPGA in Vivado. So this is the design we are going to do for this project. It's simply a 4-bit LED counter. So this does nothing but blinking of LEDs. Here, what we have did is we will be applying the clock and we will be designing a simple clock divider to divide the clocks so that we can see the LEDs blink. So we need the clock divider so that we can see the LEDs blink smoothly. So this clock divider will be providing the clock to the 4-bit counter, and this 4-bit counter will be sent to the LEDs in the FPGA. This is a simple project and we will be designing the RTL for this project now. Open Vivado, create a new project, click next, and give a project name for your project. So here we will be just saying 4-bit LED, and it'll be storing it in the right location, and it's an RTL project. And if you're doing any other projects like a post synthesis project and IO planning project, you can select them, and we will be doing another videos for these kind of projects too in the future. So do subscribe and follow. And for the RTL project, click next. And here we need to add the sources, but for now let's leave it empty and we will be creating the sources manually. So next, and the constraints, we will be creating that manually too. Next. And we need to select the board or the parts we will be using for the FPGA. And this is something important so that whatever FPGA board you have in your hand must be selected properly so that the constraints can be designed correctly. So if you are having any basis board or the RTX board, you have to select properly. And I'm going to select RTX 7 for my project. So you can select it and give next and finish. It'll be creating our project and it'll take a quick second. And this is our view on the Vivado page. And let me give a small glance on what this view is, and I'll be going through the design next. So you can get an idea of what Vivado can do and what is the basic things that we have to know in Vivado to generate a bit stream for an FPGA. So right here in the left of the page, we have the flow navigator, which will be having all the flow of the project. Right from the project manager, we have the settings and source heading and couple of settings and the IP integrated where we can create our own IPs. And we can also use the inbuilt IPs, which will be like clock dividers or filter designs and much more in there. And then simulation. This is the first thing we have to do after writing our RTL. This is for simulation, and we have to synthesize our RTL and implementation and program generation like the BitStream. This is the flow navigator. We'll be using it for the couple of processes in the next steps. And this is the project manager. We can see our project's details in here. And this is the console where we can see the runtime operations that are performing in our system. And the messages, logs, report will be available in here. And the design runs will be printed here. We can just go through one by one in the upcoming videos. For now, let's start with the RTL. So here, first we need to create our file. In the design sources, right click and add source. It's a design source and click next and create file. It's a Verilog file. We can name it as counter top and the .v extension will be automatically created for it and click finish. And then we can specify the ports here, but we can do it manually in the code itself. And now we have that design source. So you can just clear out all these things above, and you can come up here and you can start write your RTL. So first, let's see what we are going to design. This is something we have to design, right? So we are going to build all this in a single file. So first, let's specify the ports. We will be having the input as clock and reset. And as the output, you will be sending the LEDs, and which will be like a 4-bit LED. We are going to operate in 4 LEDs in the FPGA. And let's set the input as fire. And now this is the input and output for our project. And next we can go into the file. First, we need the clock divider, right? So it's a register of 27 bits. So 27 down to 0. This is our clock divider. And we can create our always block. First, for the reset, we can reset the signals. If reset, then we set the clock divider to 0. Likewise, we will be setting the LED to 0. And here we have specified the clock divider as 27-bit because we will be using the clock of 100 megahertz. 100 megahertz, which will be equal to 1 clock cycle, that is 10 nanoseconds, which is equal to 100 million clock cycles per second. That's why we are using 27 bits to mention 100 million as a number. So we will be setting the reset, and on not reset, we will be doing our logic. And this is the logic right here. If the clock divider reaches 100th clock, like 100 million times, like in the 1 second, it should switch the clock divider and blink the LED. And we'll be doing the clock divider to 0 and setting the LED plus 1. We'll be incrementing it here. And then if the clock divider is not yet for the number, and we will be incrementing the clock divider. Simple. It's a simple logic. But one thing, in simulation, we cannot wait 100 million clock cycles for to complete. So we can set this number as a parameter so we can change it accordingly in our test bench. So here we can add a parameter, create a variable called max count. And with this max count, we can check the clock divider whether it reached the max count or not. So we can set this parameter from the test bench itself. Now it's time for the test bench. Now in the sources, click simulation source and click add source next, and you have to create a file. Similarly, create counter test bench. Finish. And now we have our simulation file. Clear everything here. And now we don't need any ports for the test bench. And we can write the logic here. I have wrote a simple test bench for this design, which is nothing but a clock generation, which has the clock reset and LED signals, and we have connected to the countertop as a UD, and we have generated the clock with 5 seconds delay for each switch, which is nothing but 10 nanoseconds for one clock cycle. And next we have the clock switching, and after 20 seconds delay we would be resetting the signal and waiting 2000 seconds to finish. And in the meantime we will be dumping the variables to VCD file and monitoring the LED for the simulation purpose. Now it's time for the simulation. Save the files just by doing Ctrl S and go to the Flow Navigator, and under the Flow Navigator you can find the simulation and click Run Simulation. Before running the simulation, just ensure that your main file, that is this counter.top, is set as the top file. Just right click on it, and here you can see set as top. And if it is already set as top, you can see this symbol right before the file name. So just ensure it and go to the simulation bar and click Run Simulation and click Run Behavior Simulation. And after the simulation is done, you can see the scopes, objects, and the simulation view. You can just close the console and Flow Navigator, and you can go to the waveform window, and you can see the clock reset and the LED signals here. So it have already generated until 1000 picoseconds, and you can just click this icon to make the entire waveform fit into the screen. So you can see in the simulation, we have set the parameter as 9. So it will be switching the LED for every 9 clock cycles. So in the waveform, you can see for, let me zoom it a bit. So you can see the clock cycles. After every 9th clock cycle, it will be switching the LED. Like it will be incrementing the LED to 1 and 2, and it will be goes on further. And this is the simulation of a simple design. And in the next video, we will be going through the next steps in the FPGA flow. In the next step, we will be running the synthesis and implementation. And in the further videos, we will be doing the schematics generation, analysis, and much more. And finally, we will be doing the BitStream generation. And like this video and subscribe for the next videos to be notified. And let's see it in the next video. If you find this video useful, drop a like and comment down. That will be so helpful for me to make more content such as this. If you are into VLSI and electronics, subscribe. And if you want to learn more about such kind of topics, follow me on Medium to read about it. We are also building a Reddit community to share weekly updates too. All the links are in the description. Thank you.